Hello again, a new test today. Well, I have this rechargeable lithium battery. That's a PRM-12-1800. This one had been used for live video and photo lens. It's a lithium battery, a 12 volt. That means around 3 cells in series. Let's take a look inside. Evidently, 3 18650 cells, 3 controller boards. I suppose the circuits are BMSs and charge controllers at the same time. I never saw this kind of configuration. So they are in series. It gives a possibility to have any kind of voltage possible, just sharing the cells and the boards. Let me have a little test about discharging first, because I'm thinking to use this guy, apply my TS100 on the run. And here I have a very simple cable. Okay, power on, TS100 it's on. What I can say for now is that the temperature is growing slow. TS100 used to be up in seconds maximum. Now it takes half a minute. We can measure the current with my clamp, and we have 1 amp point 10 or something anyway. All I can say for now is that the battery can supply at least 1 amp, 135, even more, to TS100. But let's try to do some real job. Okay, 144, 146, and this is a really big surface to be heated and melted. Come on, 144. And the battery is pretty able to do these stuff. Okay, let me keep the TS100 there, still hitting the surface. It's a huge surface there. Okay, let me turn this on too. I will just turn it off to see the temperature went down to 315 degrees, and the amps are 1.442. Let's see the temperature on this chip, 42 degrees. That's not a problem. Only 24 degrees for this guy, but still working. Look there, this is a huge surface, you know, so you need a lot of power too. Well, I may say it can be used on the run with TS100 soldering iron. Very interesting configuration. I never saw anything like this. 3 controllers in series. Let's take a look at these circuits. The main circuit here, and the single one in fact, it's an MP03A. I couldn't find any kind of reference about this kind of circuit. And we have a 0.2 ohms resistor and nothing else special. There are no more active components on the board except that circuit. Okay, let's dismantle this guy. I forgot about the microphone, sorry. And let's take a look behind the board. Alright? We can dismantle this board. Okay, and let's take this out, and now we can have some measurements. The internal resistance of the cell itself. This is a 18650 from, they cover this, I don't know, but it's looking good. If it's a good cell, we should have around 25-30 milliohms, something like this. 041, 040.2. Okay, what about the other cells? 032. I'm not sure. Let's take the boards out. 032. That's a very good one. 040, 039. Okay, so that means this is a really good one. Let's take out the board and let's see if it makes any difference. I don't think so. I really don't think so. You see, this is soldered, welded to the battery, so the single way to take it out is just cut it. And then I put a piece of soldering wire back again. Let's see, minus and plus. 32 milliohms. I don't think it makes any difference. If you are trying to measure this, no way. Let's try to understand how this board is working. So let me grab a piece of paper. What do we have the other side? So we have a power plus, V phi, C phi, they are not connected anyway, and the P minus. So this is power plus, power minus on this side of the board. No more electronics here, just connections. So you can imagine we have this kind of circuit. It can deliver 1.4 amps without a problem. We can extend all of this with 10, and have a really nice, I don't know, maybe a 42 volts battery with a single controller and BMS for each cell. This is marvelous. Okay, let's put the things together. And yes, it's working. Okay, let's check the voltages. We should have almost 12 volts. Of course, 12.09. And what else I can do is to have some thermal pads to help dissipating the heat. These are silicone thermal pads. I'm going to have another multimeter inserted in the circuit to see how the charging chip is reacting. Okay, so the LED is on, but obviously we got no, or just a 11.7 milliamps current because of the LED. So the LED is taking this power. In fact, if I push the button here on, we have more than 20 milliamps, so that's why you have to go to a higher level. So now we are charging with 680 milliamps. Oh, that's great. So if you remember, we've been starting with 12.6 volts. 12.8 now. Okay, so just let it run for a while. Obviously it's charging. Yeah, so it's looking that the charging, it's working as it should. We got no more charging, 0 amps. We have a 12.26 volts. That means divided by 3, like 4.05 or something. Okay, let's turn on the power supply. Okay, now it starts having a 0.67. For how long? The voltage is running up to 12.93. It should stop in a split. Let's wait for that. Any heat? No way. $24, nothing special, and there we are. The charging went out. So the BMS and the charging, or whatever is doing this, PM03 is doing a great job. Let me have another test, and what I am trying to do now is to increase the voltage. Oh yeah, but the voltage, it's always 14.94. If you go down, we have the voltage from the battery, 12.25. We raise the voltage, and we have a 0.74 amps charging, but I can tell you we are around 15 volts from the power supply. Goes to 13 here. Now the BMS should stop everything. Not yet. Yeah, right. And here we go. It's out. Yeah, that's a very interesting idea of using these circuits. Finally, let's have a recap. So it's something like this. These are the three circuits here with okay, so we have minus going in, plus going out, is going here, another plus going here, minus, and finally the plus goes out. All right, here we have the cells. Minus, minus, plus, plus, and plus. This plus goes through that resistor to the plus of the battery, and minus comes in here through the IC, and obviously over there. Okay? And then same story to all these other cells. Minus, like that. Okay, plus come here, and minus through the circuit comes to this guy. Let's have some colors on it to be sure that we understand. This is the plus going to the resistor and to the battery. Another plus here. Resistor and battery. That's a load. Resistor, in fact. Okay. Not a. That's a current resistor. So the difference between in and out of the resistor is taken by the IC and changing, obviously dependable of those voltages, the in and out. So here we have the minus. Everything happens on the minus side, in fact. Okay, and here we have the minus going to the other battery all around. Okay, cell number 2, cell number 1, cell number 3. Now the plus from here goes to the minus IC and the cell. And finally, oh sorry, that should be red. And finally here we have the general plus, and here we have the general minus. Well, this is a very interesting way to put the things together, and taking this kind of circuit, which I couldn't find any kind of documentation on technical specification, then you can build a battery of, I don't know, 10 in series, and each of them having its own controller and BMS. This is wonderful. Very interesting concept. Okay, if you have any information about this circuit, this is MP03A, or another kind of circuit equivalent of that. Anyway, this I think it's working with TP4095, I called. I never tried to have those kind of circuits together in series. This should be interesting.